Okay, today we're going to talk about the very famous, important topic, RAW versus JPEG. It's going to be an advanced level course, not for beginners. In photography, the normal way to make an image is JPEG. So many people, they will only load the JPEG. But JPEG has lots of advantages, some disadvantages. So professional photographers, they say, yeah, you want to have the original picture coming out of the camera, the RAW. That's the best you're going to get. It has everything the camera has captured. Better it is not going to get. But a RAW picture is something very raw, not usable yet. A JPEG is compressed, so it has some artifacts due to the data reduction. But it is also optimized for already being ready to use, to view, to display, to print. Now, of course, the optimization could be good or it could be wrong if you desire something else. Now, because of the name, some people think that the RAW is kind of like meat and the JPEG is kind of like cooked and even overcooked. And then from here you can go to there, but you can't go back. Now, we'll see that it is quite more tricky than that. So there are a lot of myths and inaccuracies. One of them is that you're not a real photographer if you don't always shoot RAW. Well, that's not necessarily true. It depends on what you want to do with your images, how critical they are. Let's not forget that if you shoot RAW, you have a lot of operations you need to do yourself. So if you have 1,000 images, you have to do a lot. If you shoot for newspaper, print, where the quality of the image is not good anyway, in the end it's going to be small images, usually very bad printing quality, I'm not sure whether you always need to shoot RAW. It is not necessarily cooked. It looks like you can't do anything with it anymore with the image. If it's too dark, you can't brighten it. Well, you can also do that in JPEG to a certain degree. It may sometimes be better to do it in RAW, but lots of problems can be cured even in JPEG, we should not forget it. Some people say, I don't like the automatically generated JPEG images. Yeah, but if you shoot RAW, you have to do it yourself. It's not necessarily that, well, if you have kind of a particular taste that may be artistic, but also people other than you may not like what you do. And also, let's not forget that maybe your camera is in the wrong mode. Modern day cameras, even the smaller ones, they have lots of what they call profiles or picture modes or LUTs or whatever the vendor calls it. And you can select the mode which is a little bit darker maybe, or a little bit more contrasty, or a little bit more colorful, and so on. And maybe that's the way you want to always do it, your RAW processing on the computer anyway. So why not do it in the camera like that then? Another very strange misnomer is that RAW is a negative. There's no digital negatives. There's of course photography standard called DNG, digital negative, from Adobe, but actually all these things are just measured red, green and blue amounts in the color, and that's a positive. But of course the reason why people started to call this negative is because it's like in the old days you needed to do all your processing on the negative because you couldn't just show it, you couldn't just use it. It looked very strange, almost unwatchable. And that's why they use the analogy, the negative is not ready to show yet, you still have to process it in software. But I would rather call it the name it has, namely RAW, straight from camera. Question is whether all of these statements make sense generically, because it all depends on the situation you have, obviously. There's a difference also between photography and videography. First of all, in photography, there's only one way to code images up to this moment. There could be other ways, but they're not popular. And then there's the RAW. In videography, you have all kinds of options that you can choose. MPEG started becoming better and better every 5 or 10 years. But that means also there's a lot of settings you can do. So if you're talking about the quality, maybe MPEG 2 would have too bad the quality for the professional photographers, but maybe HEVC still, which is a profile for still pictures you could use if you wanted, maybe it's good enough. A lot of bad press against JPEG, I think, stemmed from the beginnings of the year 2000 and even the end of the 90s when digital cameras first appeared. Yeah, they were so very bad. They were the quality of a video recorder, more or less. They even started out like that. So yeah, that was of course not good enough for any professional use or any reasonable quality use. And also now it depends on JPEG. It does make compression errors, but depends on how strong you set the compression. If you don't mind much about the data, because RAW is going to take up a lot of memory space anyway, you can set the compression of JPEG very, very slightly, and then probably the quality is going to be quite good for most applications. So in video you have all kind of other possibilities, but it also has the problem that you have huge chunks of data because you're shooting so many images per second. So there, RAW is not such an issue. On the other hand, of course, a video picture you can't scrutinize because it's gone before you have seen the mistake somewhere. And of course, if you hang your photo on the wall or in a museum, people may look at it for half an hour. So it does have some more strict requirements. So in the beginning some cameras outputted a certain TIFF, not TIFF container but the TIFF compression, but it was not so popular. And there could be other picture standards, like for example WebP, or well, in the high dynamic range era things may change, and it may happen that there comes a new universal standard in addition to JPEG, because JPEG is not really tailored to do this modern quality level, and it's already a very old standard. And with high dynamic range I don't mean these pseudo color things that you see, which are actually low dynamic range, but the really very high quality capturings where you have very light and very dark regions in a photo. But up to the moment, JPEG is still king. One problem with RAW is that it is a secret, quite proprietary format. And hacking may be a bad thing, but sometimes also a good thing. Luckily, some people have hacked all these formats, and we now know more or less how to handle them. And you can in software of Adobe, for example, because you don't want to be dependent only on whatever the camera maker likes to provide to you. However, the Adobe people try to make a universal digital negative format, which saves all the various RAWs into this format, although it still contains some of the aspect of the original RAW. So one can ask, is this universal or not? That's an interesting discussion, and not all the cameras can save in such a manner. And also the other thing is that not everybody likes it, maybe because they want to protect their secret. So basically there's some specific tricks for RAW processing, whatever camera you have, and then there's JPEG, which everybody can do in the same way. So if you want to save something for the internet, for example, this would be a good way. Now, to understand deeply what is going on, to be able to make up our mind what for your specific use would be most interesting to do, we have to take a look a little bit at how does a camera take an image and store it. So what happens in how do you measure all these photons, all the colors in the world? We will have detailed courses, detailed videos on how exactly a color can be measured and what it is, but we'll look a little bit in here also. What is an original camera image and what makes it so special? Why is this camera, what's so special about a missing pixel, for example? You can have a faulty pixel which shows up red in the image or whatever. Why not correct it? Why is it so special to know that you have a faulty pixel at that location? And what's an optimized image? Because each camera will write its own interpretation of the JPEG. It will say, look, I think this is the best. Another camera may do differently. And that's the problem with cameras. Some cameras may give quite decent images, others may not. And then you may be forced to go to the raw method to do everything better yourself. So raw is just an original. It's not a true image. It's not really necessarily the colors you see out there in the world, because, as we will see in another video, cameras cannot really measure accurately the colors that humans see. It's just an approximation. It's also not the best image. It's not, well, the best image is possibly a very something which depends on taste and the situation. So yeah, can an automaton do that? But RAW doesn't do anything. It's just capturing whatever the hardware of the camera does. What is a master? Master is some image we would like to store as our first image, and then we can derive whatever image from that which we need. Maybe we want to optimize it for printing, maybe we want to make another image for the web, maybe we want to make another image for a cup of coffee to print it on the cup. Well, should the master be the RAW? Should the master be sometimes the JPEG? If you shoot only JPEG and there's no RAW, then you don't have the RAW. Or should it be the digital negative, maybe, as an intermediate position? It has the advantages of being still more or less mostly RAW, but on the other hand also standardized, generally usable and recognizable, which may not be the situation with a RAW file, because it's a secret code, and some people have, if the camera maker goes bankrupt, which happened with Kodak for example, you may suddenly lose your, maybe you lose the software, the computer, whatever, you lose all your photos. That's something which especially museums are very scared of, so we want to have something which is universal. That's one of the pros and the cons again. Now, we will have to look at how to light and how to make a picture, because RAW is not a magic wand that cures all the problems you do as a photographer. Like I said, if you shoot an image too dark, you may be able to re-optimize it on the computer, and that might be more easy in certain situations with a RAW than a JPEG. In other situations, a JPEG will work fine, but none of them will solve that problem. It's just, sometimes indeed the wrong picture will still look quite nice, and sometimes you will just be looking at the noise of your camera, for example, whether you shoot as RAW or as JPEG. There is another very misunderstood concept, 8-bit versus, for example, 14-bit. So that's not something which is linear. 14-bit is not almost 2 times as good as 8-bit. It's not even 2 to the 14th divided by 2 to the 8th, power 2 to the 8th better, which some people may think. Because it all depends on how you use these bits. Theoretically you can, if you do it smart enough, even make a better or almost as good 8-bit image as you could make a not so good 14-bit image. So it could even be that 8 is better than 14, provided you use these bits in the smartest manner, which is something you should understand. Often, of course, the more bits you have, the better, because it's additional data, but it depends what's in this data. It's like when people say, my printer can print 1 million colors, but if these are only 1 million greens and no red, you still don't have a very good printer. Compression, we'll have to see what really goes wrong in compression. Why are people so dead against JPEG? Because JPEG does do compression. What is a good image? What kind of improvement do we want? I talked about a very easy one, brightening if it's too dark, but you shouldn't shoot too dark to begin with. Maybe you just want to saturate the colors a little bit more, or that's all the kind of things you may want to do as a photographer. Improve the skin tones. You can do that either in RAW or in JPEG, and many times you can do it in both, provided you do it correctly. So don't blame JPEG with things which stem from another problem. But as I said, the codec is rather old and displays are becoming better, cameras are becoming better, so we may see a new it's already appearing, HLG still photo, but it's a detail we don't need to talk about right now. The whole core about whether you want to shoot JPEG or not is whether you lose data, whether it's reversible. Obviously, as I said, I can bake my raw steak into a baked one. If I can fully unbake my baked steak into exactly the same raw one again, then there wouldn't be any difference. Then why would raw be better? Why would I have to choose? In practice, reversibility means, can I do whatever optimization I may want? So I start doing something and everything goes exactly as I want, then JPEG would be perfectly fine. If suddenly I run into a problem, like I'm missing some bright data or I'm seeing too much noise from the compression, for example, artifacts, then it's not fully reversible. And some people, mostly in the movie world, they call this baking in. So it's typically used for LUTs, which is a table which uses a nonlinear calculation on the pixel. So you start with your original pixel, red, green and blue values. You do some transformation, you get secondary pixel values, red 2, red, green 2, blue 2. Question is, can I do the inverse calculation back to the red 1, green and blue 1, or is it baked in and I can't unbake it anymore? Well, most of it can be unbaked, but the reason why they called it also bake in, if you push the save button, you have these secondary red, green and blue values. And then, if you don't know what you did, if you don't know the function you used, the LUT you used, you cannot undo the LUT. You can undo a lot of things, but you have to guess what happened. So people mostly like to save the LUT as metadata, and then each time computers have become fast enough to do these calculations on the fly, so each time they want to see the baked in, they do the calculation again, but they keep the original values. In that case, the processing, the optimization, the optimal look is there, but it's not in the data, it's not in the red, green and blue, so it's not baked in. So if you're raw, plus a recipe how to cook it, and you cook it all the time when you need it, but you keep it raw. So now, after all the boring text-based enumeration of all the properties and differences between JPEG and RAW, I want to start showing you things, what's actually happening, so that you understand in depth. I'll start with something, image compression. Many people may not know exactly what that is in detail, and it's the single one of the properties of JPEG which is the most feared, I guess, because anything you change on the image, any aspect you lose, may haunt you later when you start to optimize the image. So what's actually happening? Now, especially in movies where you have lots of images to save, of course, but also in photography, you're getting bigger and bigger camera sensors. So you may have 40 megapixel images, and you may shoot 1,000 or 10,000 of those during a holiday trip, for example. So it would be good if you could, for example, have this 40 megabyte of raw data and you could compress it 8 times so that it's only 5 megabyte. If you use some mathematical tricks which throw away some data, but in such a manner that you really can't see the difference. If there was absolutely no visible difference ever possible, then why not do this? Of course, the keyword is almost, because there may be a slight difference, and the problem is the JPEG creator may determine what the human visual system is going to see for a certain image. For example, in the sky, the JPEG determinator knows that human vision doesn't see so many differences when an area is bright as when it is dark, and also when it is very dark it may not be so important, so it may start saving a little bit on bits there. But then if you darken the sky or if you brighten the dark parts, you may suddenly see those differences much more, because you're doing something which the JPEG engine didn't expect. Of course, if you take a very high quality compression, dropping only a few bits, and what is called fine as a setting, for example, then yeah, the problems may be so small that even if you start processing the image, it may not be a problem. But there is some price to dropping bits. What you shouldn't misunderstand is that there is a lossless compression. People telling you not to even do lossless compression, they don't understand what lossless compression means. Lossless compression is a better mathematical trick, but you can use it only to a certain degree, to a certain amount of data reduction, which is such that there is absolutely no difference whatsoever, ever, between the original and the compressed data. So you can go back exactly, you can recover each and every one of the original bits. So why complain about that? How does that work? This works with visual tricks called discrete cosine transform and such. It's not important. This works with tricks like I can explain you with this text, this word. So if you normally have an alphabet of 32 characters, you can show that you need 5 bits for each character. And you would start defining them one by one. So the A would be all zeros, the B would be the next one with a 1, then you would have the C, which would become 1, 0, and so on. However, you can use a definition with a variable amount of bits, as long as you agree that you know which is which, and then you can make the very often appearing characters, they get shorter codes, and the very seldomly occurring characters you can give a very long code. So it just works based on what you expect. You would need a lot of bits if you happen to have a text with lots of cues in it, but normally you don't get that text. So on average, if you have a text, you will get less bits than the 5 per text character. So these tricks are perfectly lossless. And that's what RAW tries to do. A lot of it may be lossless if there is still compression, so don't be scared. However, sometimes there is also lossy compression, and that can lead to annoying results. Especially people who have very critical uses of photography, like in astronomy, they will sometimes see a nasty property of even the RAW. So the RAW isn't that raw always as you should think. Okay, let's see in practice what is lossy compression. You don't see it so much on the image. The image looks fine. But if you zoom in, you get, for example, these blocks. These DCT blocks are approximated, and one of the problems is that you can clearly see the boundaries between the blocks. That is, if I on purpose use a bad setting. So I don't use fine JPEG quality, I use rough, coarse quality. Lots of bit dropping. That may still be fine if you save this image as a small image for the web, but not as a master image, because then this is what you have to work with later on. If you save it for the web and you show it small, this may still not be an issue. Of course, you can set your JPEG much finer, and now people may have to put their nose close to the screen because there are some small pixel things here, but if you print this or you make a poster of it, you probably won't see the DCT blocks. However, again, it could happen that if you start processing that something is exaggerated. So, I've shown a little bit. This is how you would do it. It's still a JPEG, mind you. I remind you, it's still a JPEG, but if you do it optimal quality, it looks smooth. If you do it bad quality, you get all these blocks and in the shadow here. So if there's a little bit more yellow, the JPEG generator just says, I'll just make it a yellow block. So I'll approximate it very, very roughly. Here, this Actually, to be honest, this is kind of a mistake of this particular JPEG generator. Although it's a very commonly known popular image processing tool program, but here it went totally wrong because I used a setting for the demo which was absolutely exaggerated. Normally you wouldn't do that, but it went wrong with these kind of fatty droplets on the edge of the pan. And now you see exactly how JPEG works. It works by creating these chessboards. And the mathematics shows it that you add a lot of these chessboards together, you get a very normal structure again. But the problem is if you throw away some of them, then you don't generate the full image structure and you end up with something like this. So that looks... This is exactly what could happen. I'm scaring you now, and maybe you won't ever use JPEG anymore, but normally this shouldn't happen. Now, here another one, all the banding is something which you typically may have. And if you have to start processing with this, it's not easy. It's never going to be good anymore, but you can get a long way trying to improve it if you must, but it's never going to be perfect anymore. Also, raw processing, whatever you do, may work in a linear representation of the colors, and JPEG processing is usually a non-linear representation, and it also has some differences which may lead to faces which become too orange, for example. So that's something you may see, but that has in principle nothing to do with the JPEG, because you could do linear processing on JPEGs also, but for some reasons programs don't do that. So that's also something you may happen to like with your raw processing. It is a little bit unfair because I used the setting just to demonstrate to everybody, also with a bad screen, because the point I want to make also is the quality you need depends on what kind of screen you have. If you have a perfect, bright 4K resolution screen, you're gonna see all that stuff. If you're watching this video on your mobile phone, sitting somewhere in the sun, you may not even see these artifacts. So then you could say, well, who cares? It could be good enough. But the problem is, of course, if you're gonna make a master of your image, you may want to do fantastic things with it later. You may want to blow it up and show it in a museum, very large. So then you need to store a good original quality, obviously. But if you do JPEG very well, then it can meet almost all desires. That's also one of my statements. Almost all desires. And also some customers may not like it. They may demand for it. Here, even with this very bad image, I did process it a little bit in JPEG, and I managed to mask even these very ugly chessboard patterns that we had there. But it can be a lot of work, and as I said, this may be much more work than a normal raw processing approach. And for what? Because you're never very sure what comes out. However, if you store your JPEG images at the highest quality, and you do that very well, then usually you won't have too many problems if you work smartly. Okay, so what is a camera? How does it take an image? Let's look at our photo professor here, and has seen something very nicely, and he wants to take a photo of it. What does a camera make? It has usually, for each location, it needs to take a color image, so it needs to determine how much red there is in this color, this orange color. There's going to be a lot of red. There's not going to be a lot of green. There's not going to be a lot of blue. So this number will be high, these numbers will be near zero. And then a little bit further down the line, or a little bit further downwards, you will see white, for example, and if it is white, then all these cells should give the same value, 255, for example. Now this is not a nice image to see. If you were to directly render this on a display, you would see something which is quite too green, because there's lots of green in it. For capturing, there are reasons why to do this, but for displaying you don't want to do this. So what we have to do is a so-called debuyer, and we have for each position, we have to calculate not just the amount of red that was there, but the actual color. which was this, for example, and it has a lot of red, but it's a little bit yellowish, so it probably also has some green. How does that work? You interpolate. You see that there's a certain amount of green around this position, and you just take the average of these four, for example. However, there are different algorithms, so that already makes a difference. So that's one of the aspects of going to RAW in the computer. You could choose exactly the same debayering algorithm as your camera, but you also could choose a better one. If suddenly there's a new one which you like more, choose the other one. And the debayering, different algorithms have some different properties. Some of them make the image more blurred, more unsharp, some of them make them more sharp or whatever. And for some people this may be a selling feature. And they may start to see this difference as a good thing for the way they like to take photos. And if your camera then always uses the sharp one, which gives perfect photos, but the photographer likes the more blurred one, he may in software use that different kind of debayering because it creates a look he prefers. So actually, as I said, on a display you don't want to have this structure with two greens, you want to have a structure like this. Red, green and blue, next pixel red, green and blue, all very small pixels. And you have to calculate these compositions. So instead of 4 values everywhere, you want to have 3 values everywhere at each position. This is also supposed to be a linear measurement, so it just counts the amount of photons. If you see a value 400, then that's 2 times as much as if the value was 200 photons. JPEG is not linear there because you need to squeeze everything in 8 bits, you have to do it smartly, and that becomes non-linear. Now, you already see one maybe disadvantage of the RAW. Some cameras have a totally different structure. There are cameras that have, instead of a green pixel, they have an emerald pixel, which captures a little bit of green, a little bit of blue also. And the camera maker, for example Sony has this, says, this gives me a better characterization of the actual colors. As I said, the colors which a camera calculates are just an approximation, hopefully a good one. If you store this as a RAW, you will obviously have a different set of data, so to be able to interpret it, you need to do another debayering mathematical trick. This one can also exist, for example in video cameras. So who would know the best how to convert that? Probably the camera manufacturer. He has tested for lots of colors how exactly the output behaves here and what real color in the world there would have been. Now, of course, an Adobe or whatever other software maker can also gamble that and do a lot of tests. You as a person, maybe not. So maybe the color is not so critical, but sometimes it is. Luckily, the camera can guide you by saying, probably I would use this. But this is an important first step, and personally, I would think, why would you really want to know this 4 pixel structure in a RAW? Wouldn't it be just as good if you had a very decent universal representation, reversible also, of just these 3 measurements? Because that's actually what you're gonna need for a display anyway. So that would be my point. You could just as well have a RAW format which makes this, because nobody's gonna use this. Also not for printing, this is not the way you print. In printing you're gonna use inks, so it looks a little bit like this, with cyan and yellow and magenta, but it's also not exactly the same thing. So why not start with something like this as a RAW? In my opinion, it would be just as good. What do the pixels then measure? So we have here now 3 adjacent, what you can call pixel wells. They actually capture photons, and these photons are converted to electrons because electricity we master and we can measure very well. And via something called an ADC, analog digital converter, they convert this count of, let's say, 5,000 electrons into a number. Also, that number is quite arbitrary depending on the camera. Some camera may have... Interestingly, this ADC is something you don't find usually in the spec of the camera maker, although it's a very important thing, because this is your accuracy of your color. If you have only a 12-bit ADC, because these are linear bits, and then the amount of bits does give you the precision of your color, because they're just linearly allocated, just stupidly measured. So this is a very, very important property, although it's never mentioned. But it also depends on the camera, and of course the hidden story behind it, it depends on the quality of the sensor. And so if you have a very expensive sensor, then you may have very precise 16-bit measurements of the red and the green and the blue color components in a certain pixel. If you have a mobile phone, then you may have very rough measurements, and there may even be a lot of noise in these measurements, which is another thing. So that's the main thing. It's not so much that these numbers are arbitrary, it's also that these numbers may be good or bad depending on which sensor you have. And then you can say, I want to have a RAW because I want to have the best quality possible. But what if the mobile phone is already bad quality anyway? So in the beginning, mobile phones didn't even bother to output RAW. Well, it may be a marketing trick, and also people started hacking and such. But the thing is, some mobile phones make such bad JPEGs unnecessarily that even there the JPEG is much worse than it could be. So that's another reason why you maybe want to have the RAW. Even if the mobile phone camera image is not quite good, the RAW is still better than the JPEG. But it doesn't solve the problem though. So now we know we have all these numbers coming out of the ADC for each pixel color, which can run, for example, between 0 and 65,535, and it depends on how much red there is and blue, how much it gets filled. How do we save them in the memory card? Well, for RAW we could just save the numbers. There could also be some mathematical trick involved, like taking the square root of these numbers. There can be lossy compression even, as we said. But how do you make JPEG numbers? JPEG is standardized to have a number, to require a number always between 0 and 255. So how do you convert these numbers to these numbers? Well, you could use the square root, it would work, but it's not necessarily the best thing. Remember that we said that the JPEG, one other goal, major goal, was that we wanted to have an optimal image, which you could directly display on a monitor or television, or directly print. So you need to do a smart allocation here. And the camera maker would need to figure that out. Also, if the numbers go only to maybe 20,000 or to 120,000, we always need to find the optimal mapping to these values. And that's not so easy. And it involves a number of concepts. Two of them I want to explain because they are quite important. It's banding versus clipping. Now I'll make it simpler for the people who are not so mathematically inclined. Let's suppose my original numbers are 0 to 20. And my JPEG can do only 0 to 10. How do I map this? Well, dividing by 2 would work quite well. And indeed I could, we talked about reversibility being the first most important property of whether a master image is stored correctly or not. We could invert this, because we just have to multiply by 2 again and then we get these numbers. But the problem is that there are rounding errors. So a 5 could have been a 10, but it could also have been a 9. And what that will lead to, differences which are jumps here, because the 9, we didn't know it was a 9, so we'll probably call it 10. And the next number would then be an 8, and the next number would then be a 6. And maybe these jumps are too big, and you will start seeing it. We'll see that in the next slides. I could of course do another thing which keeps all the precision here, but then I clip away all the values above 10. Now this is not invertible. Here these numbers are easily invertible because they are exactly right. But these numbers, they will all become 10. So I don't know whether the 10 was an 11, a 12, a 13 or a 20. So it's gone. So clipping is really bad artifact. Unless of course I have an image where everything is only here. If there are no bright regions, which often happens, then this may be even a better trick than this. But these two kind of errors, you constantly have to weigh which one of the two is going to be worse. Because if you have to put a large set of numbers in a small set of numbers, there's only one thing you can do, two things, sorry, you can do. Indeed, either you squeeze them by dividing by 2, or you drop a couple of numbers. But you have to choose. Now, what is that banding? We have here a very nice photo, and now I have again exaggeratedly shown what happens if you have only a few numbers. So to represent colors, which should be good colors, so if you do the multiply by 2 trick again, they fall into colors which are far apart, which means that they look quite different. So we see that mostly, interestingly, it depends on what kind of image you have. In the textured regions, you don't even realize that I have banded, or also called posterized, my image to too few values. You don't see so much difference here. But here in the sky, this banding can become very bad. Of course, there can be processing tricks to remove this, but it's not necessarily easily done. And as I said, this happens because what I did now is divide by 5 instead of divide by 2. So I now jump from all zeros. All these numbers will become 0, 0, 1 and 2. All these will become 5s. And from here it will become 10s. And then you have a huge jump. And you only have a couple of colors in the sky, so it looks majorly different. Often you will see always, in many photos also, that there's a jump towards the white. This is also something cameras like to do, because the problem is you have 3 color channels, so if one of them starts clipping, suddenly you have not enough green, for example, and you start not seeing a major jump in brightness or anything, in the strength of the blue, but the blue can become suddenly more greenish or whatever, and that can be even uglier. So then sometimes that the brightest colors, they just say, oh, we jump to white. And some cameras, especially cheaper ones like phones, can do that in a very ugly manner sometimes, and they have a very big white blotch. But the banding can happen everywhere. There are some people who would say, if it's in a textured region, even 6 bits would be enough. Now, the other thing which can happen, as I said, is clipping, or almost clipping. So we represent this with almost the same values, and then you lose the structure of the sky. Actually, it may be there in the raw, but the problem with the raw is we have now this squeezed divide by 2 representation, so everything is a little bit grayish. Actually, it doesn't just divide by 2, but it also raises the blacks. So this doesn't look nice either. This is something which looks quite nice. It's a colorful picture everywhere, so the JPEG did a very good job, except for we always lose the sky. Now for some people that may be totally not a problem. And we also lose, for example, what we can see outside through a window when we're indoors. For many situations that may not be a problem. For others it may be. So I want to start from all the raw information, and I want to do my own processing. And then I can have something manually optimized, which looks quite similar. So I have all the benefits of the colorful look here. If you go into details, it's somewhat difficult maybe to get exactly the same thing, because then you spend like hours, but it's close enough. If you didn't see this original camera JPEG straight out of camera, you wouldn't know that in my manual software computer optimization I did something different. But the important point is now I can make both this good and I have still everything in the sky. There are fundamental limitations in any JPEG image, as I said, and in fact in any normal display, because the JPEG was tailored to be good for normal printing and normal display. It can make an image which is good enough for the capabilities of that display. And a normal printing, for example, or display, just can't make a very bright sky anyway. It can't go brighter than paper white. So there is something of a trade-off here, what you want to do. But this looks like a neat image, everything is well visible. Here you see everything nicely, it's brightly, it's sunny, it was a sunny day, and in the sky you still see much more, it still is blue, much more than here. Now in all fairness, sometimes you can get this result even by darkening the sky a little bit in the JPEG. But sometimes you can't. And a nice example is this one. This is a very difficult one. It's near the end of the day and everything is getting dark in the world. And here near the sun it can become very bright, because the sun is a very bright thing. And that's challenging even for the camera itself, and certainly for a codec, which is not optimal for an image representation. You want to have something like this, right? Now I can see what kind of moor plants we have here. I can still see the same kind of nice structure in the clouds, and I can see this beautiful orange sunset as it is supposed to be, instead of being clipped to white. This is an example of clipping, where the JPEG decided, well, all that bright stuff, it's probably not interesting, it's a small region anyway, but how can the camera know what's interesting for me? So here you would like to optimize the raw. Otherwise you don't get these beautiful pictures. Now, if I didn't have this raw stored, I would have to work based on this picture, and I might recover, although this looks bad and looks very black, by image processing it and increasing the brightness of the blacks, I might restore much of this. But this is really gone. As I said, if it's maximum 255, there's nothing above that. It was like that example with everything above 10 becoming 10. I can't see which 10 is which. It's gone. It's not there. I cannot recover this internal structure. It just isn't here. I just have this white patch. I cannot make from the same white pixels different pixels. So that's where you may end up in the limitation of JPEG. Of course, maybe you can just light this image in such a manner that it becomes even darker. And then maybe you do retain a little bit of structure here, if you expose it a little bit darker. Of course, then you may see a lot of noise or other problems in this area, but it all depends. If you have a critical image, you may want to go raw, and if you have a critical customer,